All right, well today we're doing line integrals. Dude, I think someone like spiked my cherry limeade. It's like bitter. Anyway, uh, so have you ever wondered? Also, I'm gonna try to make it make sense. I don't have a lot of time to do this, so yeah. Have you ever wondered if volume integrals are the only way to take integrate a 3D function? Well, they're not, because we can do it along a line. We have the whole XY plane to work with. Um, how? Well, let's find a way to represent the line. Because an integral, it's nice to only have one coordinate to take it on. If you're going along a line, it wouldn't make sense otherwise. So let's simplify. Every infinitesimally small change in the line will be ds, like a little length along the line. And using Pythagorean's theorem, ds squared equals dx squared plus dy squared, because it makes a right triangle. All right, so yeah. Now parameterization, we're going to represent the line as a curve, well, as a vector curve with one coordinate by just plotting its x and y points everywhere. That's basically what we're doing here. And now using taking the derivative, we get this. So we can't really work with this now because we have vector brackets. So let's take the length or magnitude of the vector at each point. And we'll get this. Now these are remarkably similar equations. And the really only bad thing here is that we have these dt's everywhere. So let's pull a 1 over dt out of the square root and multiply by dt. What do you know? We have ds, because these are the same equations, just with one side square rooted. So now our integral, we started with this. This is kind of what the whole idea was. We're taking the integral from a to b along a line. We reparameterize everything into one coordinate, and now this is actually a doable integral. So we take the integral from the beginning of the line to the end of the line, which are t naught and t. X and y of t lock us onto that line because those are the parameterized coordinates in the xy plane. And then we multiply by the ds that we found. This will work for any scalar line integral, not vector line integrals. We'll get there. Anyway, love y'all.